Hello, this is the last video, 7-7. You did it. Okay. So, we are talking about exponential decay in this example. So, the kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases by 11.5%. What is the pressure at an altitude of 5,000 meters? So we are told that the pressure decreases by 11.5%. So that tells us that we're using decay. So even if the problem didn't say it here, because it probably won't in your homework, right? Even if the problem doesn't say it here, the fact that it says decreases tells us that this is a decay situation. This is a decay situation, which tells us that when we're using our exponential formula and we're finding b, right? We're finding our multiplier for exponential function. We're going to do 1 minus the rate. 1 minus the rate. So the minus is because it's decay, right? Okay. So minus for decay, and the rate is going to go here. So first of all, we need to figure out how much our, we need to figure out the pieces. So it decreases this percentage every 1,000 meters. Every 1,000 meters. So we can't just say, oh, we raised 5,000 meters. We need to figure out how many times the pressure decreased by this amount. And that's what's going to go in our exponent, is the number of times that the pressure decreases by this amount. So remember, in the last situation, we multiplied the exponent by 12 because it happened every month. And so we had years, we had to turn it into months, so we multiplied by 12. This time we have 5,000 meters, and we have to figure out how many times it's gone up by 1,000 meters. So we have to do 5,000 meters divided by 1,000 meters, because every 1,000 meters it decreases by this much. So we go up 1,000 meters, it decreases. Go up to 2,000 meters, it's decreased one more time. So it's decreased twice. If we go up to 3,000 meters, it's decreased 3 times. If we go up to 4,000 meters, it's decreased 4 times, and so on. So what we're doing is we're doing 5,000 divided by 1,000, which is 5. And I apologize for my handwriting. It's hard to write on a touchscreen. So our exponent here is going to be 5. That's the number of times the thing that is happening. The exponent is always going to be the number of times that it has happened. So no matter what the word problem is, the exponent is the number of times that the thing, whatever is happening, the number of times the thing has happened. That's going to be our exponent. And then remember, our initial amount goes out in front. They've already got that for us. Our initial amount was 101 kilopascals, so that goes out in front. And we're multiplying by 1 minus the rate to the 5th power. So the rate, remember, we have to write this as a decimal. So that's 0.0115. Sorry, it doesn't really fit. Okay, so that's going to be our rate. So we're going to do 1 minus 0.0115. So you'll put that into a calculator. 1 minus 0.0115, which is 0.9885. So I'm going to rewrite this whole thing. So this equals 101 times 1 Nope, I already did the 1 minus. I don't need to write that. Okay. 0.9885 to the 5th power. All right. So we did 1 minus the rate, and that gave us this. So then we take that, what we just found, to the 5th power. So 0.9885 to the 5th power. And you get approximately, and again, I recommend leaving the number in your calculator and just multiplying by what's in your calculator so you don't have rounding error. 101 times 0.944 approximately. So again, if you just leave that in your calculator, you'll get an exact answer. So you multiply that answer by 101, and we end up with 95.3, approximately 95.3 kilopascals. So the pressure at 5,000 meters, the pressure at 5,000 meters is about 95 kilopascals. So the pressure at 5,000 meters is about 95 kilopascals. So basically with decay, you're just subtracting whatever rate you were given. You were doing 1 minus that rate, and then your exponent is the number of times the thing has happened. Hopefully that helps. Let me know if you have any questions.